When we have parametric equations, we have one equation for x and one equation for y, and they're given in another variable, which is called our parameter, and that is usually t. So in this question, x is t plus 1, and y is t squared. So when t is 1, x will be 1 plus 1, so 2, and y will be 1 squared, which is 1. So that set of coordinates is 2, 1. So we get our x coordinate from one equation, and we get our y coordinate from another equation. In this question, we need to find the Cartesian equation for the function. And whenever we see Cartesian, it means just an x and y. So an equation just with x and y in it, no other parameter. In the form y equals f of x, so y the subject, state the domain, which is what x can be, and the range of the function, and the range is what y can be. So we can find the Cartesian equation by eliminating t. So if we take our x equation, x equals t plus 1, and take away 1 from both sides, we get t is x minus 1. And then we can substitute in for t in our y equation, change t into x minus 1. So y is x minus 1 squared. That is our Cartesian equation. Find the domain and the range. So for the domain, that is what x can be. So if we look at our x equation, t can be between -3 and 3. So if it's -3, we get out -2. And the biggest thing it can be is 3 plus 1, which is 4. For the range, that's what y can be. If we look at our y equation, the smallest thing we can get out is a 0 from 0 squared. And the biggest thing, either -3 or 3 squared, is 9. So our range is between 0 and 9. Okay, one for you to try. See if you can give it a go. A function f has parametric equations. X is 2t and y is t squared plus 3. T is again between -3 and 3. We need to find the Cartesian equation. So eliminate t. We want it in the form y equals. So let's start with our x equation. Half both sides. So t is x over 2, or half of x. Then substitute that into y. So it's going to be x over 2 squared plus 3. And that is our answer. We could also write x squared over 4 plus 3, but that is absolutely fine. The domain is what x can be. So it goes between -3 and 3 for t. So x is going to be between, so the smallest thing is 2 -3's, which is -6. And the biggest is 2 3's, which is 6. So that's our domain. Our range is what y can be. So the smallest thing would be 0 squared plus 3, which is 3. And the biggest, 3 squared plus 3, which is 12. Here's another question. A function f has parametric equations. X equals log t plus 2, so the natural log of t plus 2. And y equals t squared minus 1, where t is greater than -1. Find the Cartesian equation for the function in the form y equals f of x, and state the domain and range of the function. So again, we're going to start with our x function and make it t equals. so we can eliminate t. So we're going to get rid of log by taking it out of log form or doing the inverse of natural log, which is e. So at the moment we can say it's log base e t plus 2. That's the same as e to the power of x equals t plus 2. E to the power of x equals t plus 2. Then take away 2 from both sides. T is e to the power of x, take away 2. Substitute that into the y equation, substitute in for t. So y equals e to the power of x, take away 2 squared minus 1. We could expand and simplify the brackets, but I'm going to leave it as it is. The domain is what x can be. So if t is negative 1, we get log 1, which is 0. And as we increase t, our log is going to get bigger. So on a graph, our log, our natural log, so it looks like this usually, but we're shifting it 2 spaces to the left. So it's going to be like this. So it can be anything bigger than negative 1. So that's our input. So our output is anything bigger than 0 because it's this part of the graph. So x is greater than 0. That's our domain. For our range, y equals t squared take away 1. The smallest thing we can get out would be when t is 0, which will be 0 squared minus 1, which is negative 1. And we can have anything bigger because as we increase t, we're gonna keep getting a bigger and bigger answer. So it can be anything bigger than negative 1. So that's our domain and range. One for you to try. Give it a go. A function f has parametric equations. X equals 2 log 3 minus t. Y equals 1 over t. T is less than 2. Find the Cartesian equation for the function in the form y equals f of x. So let's rearrange our x. So let's half both sides. E both sides, or take it out of log form. So e to the power of x over 2 is 3 minus t plus t to both sides. Take away e to the power of x over 2. So that's t equals, substitute it into the y equation. So y is 1 over 3 minus e to the power of x over 2. The domain is what x can be. So if we put in 2, we get out 2 log 1, which is 0. And as we decrease t, we're going to be increasing our log. So if we put in a negative, say we put in negative 5, it's going to be 3 minus 5. So it's going to be increasing. So again, it's anything bigger than 0. So x is greater than 0. And the range is what y can be. So we have y equals 1 over t. So on the graph, 1 over t looks like this. And t can be anything less than 2. So it's these parts of the graph. So this part here and this part here. So when t is 2. 1 over t is a half. So we can get out anything greater than a half. So this part of the graph. So y can be bigger than a half. And it can also be anything in this part of the graph, which is anything less than 0. So y is greater than a half, or y is less than 0.